Hello viewers, this is lecture number 5 on successive differentiation. In lecture number 4, we have discussed how we can find if the function is given, how we can find the first derivative of the function, and then second, third, fourth derivative, and so on. So today we will continue with the same topic, and we discuss derivative of nth order of some standard function. Derivative of derivatives of nth order of some standard functions. So let us start with the simple question. If uh, if y is equal to x raised to power n, right? So we use y1. Y1 means first derivative of y with respect to x. We also use y dash. Dash means first derivative with respect to x. Y dash means d, and we also use the symbol dy upon dx. So instead of writing dy upon dx and y dash, I write y1. Y1 is first derivative of y with respect to x. So we get n into x to the power n minus 1. So derivative of x to the power n is n into x to the power n minus 1. Now again differentiate. We get y2. Y2 is second derivative of y with respect to x, that is n into n minus 1 x raised to n minus 2. Now again differentiate with respect to x, we find y3 n into n minus 1 n minus 2 x raised to n minus 3. Okay, so tell me what is y4. You write y4 in your notebook and check whether it is correct. So n into n minus 1 n minus 2 n minus 3 x raised to power n minus 4. So this is the fourth derivative. So continue in this way, we find by n that is equal to, and someone tell me what is the nth derivative of this function. Yes, it is n into n minus 1 into n minus 2 into n minus 3 into so on, 3 into 2 into 1. So last term we have x raised to power n minus n, because for first derivative we have x to the power n minus 1. For second derivative we have x to the power n minus 2. For third derivative we have x to the power n minus 3. For fourth derivative we have x to the power n minus 4. Similarly, for nth derivative, the last term is the power of x is x to the power n minus n. X to the power 0, that is 1. Right? So we, and this is nothing but it is n factorial. So if we have a term y equal to x to the power n, what is the nth derivative of this y? That is n factorial. Okay. So let us consider some more simple example. If we take n equal to 4, right? In the above example, if I take n equal to 4, then my function is y is equal to x to the power 4. So what is y1? Y1 is 4 into x to the power 3. Y1 is first derivative of y with respect to x. What is the second derivative of y? 4 into 3 x to the power 3 minus 1 is 2. What is y3? 4 into 3 into 2 into x to the power 1. And similarly, what is y4? 4 into 3 into 2 into 1. So that is 4 factorial. 4 into 3 into 2 into 1, we can write by 4 factorial. So if I take n equal to 5, in the above example. So y is equal to x power 5. So what is y1? Y1 is 5x power 4. What is y2? 5 into 4 x power 3. What is y3? 5 into 4 into 3 x power 2. Y4 5 into 4 into 3 into 2 into x. And what is fifth derivative of y? 5 into 4 into 3 into 2, derivative of x is 5. That is 5 factorial. Okay, so if we differentiate again, so what we observe, if we have x की power 4, then its fourth derivative is 4 factorial. कि अगर कोई फंक्शन x की पावर 4 है, पावर उसकी 4 है, तो उसका उतना ही फोर्थ डेरिवेटिव हमें किसके इक्वल मिल रहा है? 4 फैक्टोरियल की. इफ आई हैव y इक्वल टू x की पावर 5, तो इसका फिफ्थ डेरिवेटिव क्या मिल रहा है मुझे? 5 फैक्टोरियल. तो सिमिलरली टेल मी, इफ वी हैव y is equal to x power 10, what is the 10th derivative of y? Yes, you write and in your notebook and check whether your answer is correct. So if I take y is equal to x की power 99, what is y 99? If I have y is equal to x की power m is any positive number, then what is ym? So I hope you all have written your answer in your notebook. Now you can check. So y10 is 10 factorial, y99 is 99 factorial, ym x power y equal to x power m, so ym is m factorial. Now 10 factorial is constant, 99 factorial is constant, m factorial is constant. So if we differentiate one more time, if I have to find y 11 time derivative of this function, then we know that derivative of constant is 0, so y11 is 0. And all other derivative, y12, derivative of 0 is again 0, y13, again you get 0. So on, you get all other derivative greater than equal to 11, they are 0. Right? Similarly, y99 is 99 factorial. So what is y100? If we differentiate one more time, so that is 0. And similarly, y101 and all other values. Now come to here, ym is m factorial. So ym plus 1, that is equal to 0. So ym plus 2, again you get 0. Derivative of 0 is 0. Similarly, that is equal to ym plus 3 equal to 0, ym plus 4 equal to 0, and so on. Okay. So can someone tell me what is y5 here? Yes, y5 is 0. What is y6? We get 0. Derivative of 0 and all other derivative greater than equal to 5, we get 0. Similarly, y5 is equal to 5 factorial. So we get y6 equal to 0. That is equal to y7. That is equal to y8. That is equal to y9 and so on. Now come to this. If we have to differentiate yn plus 1, if we have to find yn plus 1, it means we have to differentiate yn one more time respect to x. So what we get? We get 0. That is equal to yn plus 2. That is equal to yn plus 3. That is equal to yn plus 4 and so on. So take 30 seconds, go through the whole content, whatever we have discussed up to this. Then we will discuss the next part. Okay, so now let us discuss some more. If y is equal to 2x plus 3 की power 4. So we have y is equal to 2x plus 3 की power. Now we have to find y1. Y1 means first derivative of y with respect to x. So 2x plus 3 की power 4. So we can write the derivative of this is 4 into 2x plus 3 की power 3. 4 minus 1 is 3. And again we have to differentiate 2x plus 3. So when we differentiate 2x plus 3 with respect to x, we get 2. Derivative of x is 1. So 2 into 1 is 2. And derivative of 3 is 0. So plus 0, we get 2 only. Right? Now come to y2. y2. So again we differentiate. So we write 4 into 3 into 2x plus 3 whole square. Again you get, when you differentiate 2x plus 3, you get 2. So already we have 1, 2. So we find 2. We can write 2 square. Now come to y3. Again differentiate y2 with respect to x. So we get 4 into 3 into 2 into 2x plus 3. Again differentiate 2x plus 3, you get 2. So 2 into 2 square. So you get 2 cube. Now what is y4? y4 is 4 into 3 into 2 into 2x plus 3. So you can write this as 1 into 2 to the power 4. So can I write this as 2 to the power 4 into 4 factorial? So this is 4 into 3 into 2 into 1. You get 4 factorial. And 2 to the power 4, you can write 2 to the power 4 into 4 factorial. So y4 is equal to 2 to the power 4 into 4 factorial. So if I have y is equal to ax plus b to the power n, where a and b are any real number, right? So how can we find yn, or can you tell me uh, what is the value of yn and the derivative of y? You can see the result, above result. If y is 2x plus 3 to the power 4, here a is 2, b is 3, n is 4. So if you relate this ax plus b to the power n with the above example 2x plus 3 to the power 4, then can you tell me what is yn? Yn is, here you get 2 to the power 4. 2 is coefficient of x, that is a. So we get a to the power n. Here power is n. So we get a to the power n into n factorial. If you are agree that this is the correct answer, then it's good. If you are disagree with this, then what I suggest you try to find y1, then y2, then y3, and after continuing the same process, you try to find yn. And after uh, finding the nth derivative, you find that the result is n factorial into a to the power n, or a to the power n into n factorial. Okay. So now come to the result. This is the first article. If y is equal to ax plus b to the power m, then prove that yn is equal to m into m plus 1, sorry, m minus 1, m minus 2 into m minus n plus 1 a to the power n ax plus b to the power m minus n, where n belongs to natural number. So here Now if you are confident that you can find the first derivative, second derivative, third derivative, and nth derivative, as we have already discussed various example, if you are confident or comfortable with these, then I hope you can solve this article also. So here y is equal to ax plus b ki power m, and we have to find the nth derivative, not mth derivative. If we have to find the mth derivative, so we can directly write ym is equal to m a ki power m into m factorial. But here what we have to do, we have to find nth derivative. It may be the same. If m and n both are same, then we get a ki power m into m factorial. But if m is greater than n or n is greater than n, then the result may be different. But we have already discussed, right? So let us find. So we what we do, we use principle of mathematical induction to find the solution of this. So what is given? Given y is equal to ax plus b to power n. This is given, and required to prove yn equal to m into m minus 1, m minus 2, m minus 3 into m minus n plus 1 a ki power n into ax plus b ki power m minus n, for n belongs to natural, right? So this we have to prove. So we shall prove this by principle of mathematical induction, PMI, on n. So this, let this be 1. So y is equal to ax plus b ki power n. So what is y1? So what we do, we differentiate equation 1 for n equal to 1. For n equal to 1. Differentiate equation 1 both sides with respect to x. We get y1 is equal to m into ax plus b ki power m minus 1 into, again you differentiate ax plus b, we get a. So can we write this as m into a ki power 1, a as a ki power 1 into ax plus b ki power m minus 1. So if we put n equal to 1 here, we get m into a ki power 1 into ax plus b ki power m minus 1. So the result is true. The result holds. Result is true for n equal to 1. Now assume that even let this be equation number 2. So the result means this yn, this is 2 for n equal to 1. So assume that 2 holds for n equal to k. So we put yn equal to k, then k into yk equal to k into k minus 1, k minus 2 into m minus k plus 1 a ki power k ax plus b ki power m minus k. So this result is, let this be 3. So we assume that the result holds for n equal to k. Now we have to show that the result is true for n equal to k plus 1 also. So let us differentiate equation 3. Differentiate equation 3 both side respect to x we get. So if we differentiate yk one more time, we get yk plus 1 is equal to. So k minus 1, k minus 2 up to this, k minus 1, k minus 2 up to m minus k plus 1 into ax plus b की power m minus k. So again you differentiate, you get m minus k ax plus b की power m minus k minus 1, and again ax plus b, when you differentiate ax plus b you get a. So we have already a की power k. So a into a की power k, you get a की power k plus 1. So let us rewrite it. So we get k minus 1, k minus 2, so on, m minus k so a की power k plus 1 ax plus b की power m minus, we write in bracket k plus 1. So if you look equation number 2, yn is m into m minus 1, m minus 2, m minus 3, m minus n plus 1, right? M minus n plus 1 a की power n. Here you get, if you compare this n, then you get m, last term is m minus n plus 1 a की power n and ax plus b की power m minus n. So here we can write this as k into k minus 1, k minus 2 up to m minus k minus 1 plus 1. So we can write, sorry, not minus 1, here we write k plus 1 minus and this plus 1. So it is m minus k minus plus minus 1 plus 1, it becomes 0. So it remain m minus k. So what in term of because we have to write the result in term of k plus 1. So instead of writing m minus k, we write m minus k plus 1 plus 1 into a की power k plus 1 into ax plus b की power m minus k plus 1. So if you look at the result is also true for k plus 1. The result, that is 2, holds for n equal to k plus 1 also, right? So it means by principle of mathematical induction, the result is true for all n belongs to natural number. So given any n in n, it means given any n in n, if y is equal to ax plus b की power n, ax plus b की power m, so if y is equal to ax plus b की power m, then given any n in n such that yn is equal to n into yn equal to m into m minus 1, m minus 2, m minus n plus 1 a की power n ax plus b की power m minus n. This result is true. Hence the proof. So what we do here, we take y equal to ax plus b की power m, and we have to differentiate. We have to find the derivative of y n time. Not n time, but we have to differentiate nth. We have to find nth derivative, not n time, but nth derivative. So what we get m into m minus 1, m minus 2, m minus n plus 1, a की power n, ax plus b की power m. So now, as we have already discussed some examples, so if now cases, if m is equal to n, if m equal to n, then what is given? Ax plus b की power m. So if m equal to n, then we can find ym. And what is ym? Ym is nothing but it is m factorial into a की power m. This is the answer. Or we can write this as a की power m into m factorial, as we have discussed earlier. This y4, this is yn. So in place of n, if we take n m, then what is ym? A की power m into m factorial. Okay. So this is one case. But case 2, is second is if m is less than n. M is less than n. That is y is equal to ax plus b की power m, and we have to find yn. So here we have discussed, if we have to find if y equal to x power 4, right? And we have to find y5. So y5, this is our m, right? This is our n. N is greater than m. So what is the derivative? That is 0, right? So if we have m is less than n, so directly we can say the derivative is 0. You can consider the case y is equal to 2x plus 3 की power 4. And what is y4? Y4 is 2 की power 4 into 4 factorial. Now if we have to find y5, what is the derivative? What is value of y5? That is 0, because 2 to the power 4 into 4 factorial is constant. And derivative, if we differentiate y4 one more time, so y5 equal to 0. So if we have to find y6, again you get 0. If you have to find y100, you get 0. So this is the same question. If y is equal to ax plus b की power m, and you have to find yn where n is greater than m, then you always get nth derivative is 0. I hope this point is clear to all of you. Now come to case number 3. Can you tell me what is case number 3? Yes, anyone? If m is greater, very good. If m is greater than m, so y is equal to ax plus b की power m. Then you have to find yn. Yn is, then you get m into m minus 1 up to m minus n plus 1 a की power m. Is you have to differentiate n time. So a की power n into ax plus b की power m minus n. So let us discuss a simple example. If we have example related to this case, if we have y is equal to 2x plus 3 की power 4, and we have to find y2. Here n is 2 and m is 4. So 2 is less than 4. So what is we have to find y2. So let us find y1 first. This is 4 into 2x plus 3 to power 3 into 2. What is y2? 4 into 3 into 2x plus 3 square into 2 square. Okay. So now can you compare this? Can you rewrite this in term of above? So here m is 4. So we can write yn. N is 2 and m is 4. So we can write yn equal to m into m minus 1, right? And into 2 is here n ki power, sorry, 2 is a ki power, this is n, so this is 2 to power n into 2x plus 3 ki power, you get 2 is m minus n, m is 4, n is 2, so m minus 4 minus 2, that is 2. So but instead of writing in term of m and n, you can see y2 is equal to 4 into 3 factorial into 2x plus 3 का square into 2 का square. So we get, if we if m is greater than n, then we get result in form of this. So try to solve some more example related to this problem. For example, if you have y is equal to 3x plus 5 to power 7 or 10, then try to find y10. Here n and m both are same. Try to find y11. Here n is greater than m. And try to find y8. Here n is less than. So directly y10 is simple. Y11 is 0. And y8 you can use this formula. So next part is if you have y is in the form of y is equal to 1 upon x. So if y is equal to 1 upon x, then what is y1? First derivative of y with respect to x. You can also write this in term of x above minus 1. Okay? So you can write this as minus 1 x power minus 2. So here I can write minus 1 divided by x square. What is y2? y2, you differentiate this. Minus 1 into minus 2 into x above minus 3. So I can write this as minus 1 ka square into 1 into 2. 1 into 2 upon x power 3. So can I write this as minus 1 ka square into 2 factorial divided by x power 3? Or instead of writing 3, I can write 2 plus 1. I can write 2 plus 1. Let us, after second, third, fourth result, we realize why I write x power 2 plus 1 for x power 3. So now y3 is minus 1, minus 2, minus 3, x power minus 4. तो यहाँ से इसको कैसे लिखेंगे? Minus 1, you can take minus common. So minus, we have minus 1, minus 1, minus 1. So minus 1 की power 3. And in bracket, क्या है हमारे पास? 3 into 2 into 1. So, or you can write 1 into 2 into 3 divided by x power 4. इसको क्या लिखेंगे? Minus 1 की power 3 into 3 factorial x power 3 plus 1. What is y4? Y4 is -1, -2, -3, -4, x power -5. So can I write directly? -1 की power 4. Yes, 4 factorial, very good. Upon x power 4 plus 1. Now I hope you understand this concept. Why I write y4 or y3 or y2 in term of -1 की power 4 into 4 factorial upon x power 4 plus 1. Rather than कि x power 5 लिखने की बजाय मैंने यहाँ x power 4 plus 1 यूज किया, so that when we write nth derivative, then it become easy. So can you tell me what is the nth derivative? y3 is -1 की power 3, 3 factorial upon x power 3 plus 1. y4 is -1 की power 4 into 4 factorial upon x power 4 plus 1. So what is yn? -1 की power n into n factorial upon x power n plus 1. Right? So this is the nth derivative of 1 upon x. So now if we have y is equal to 1 upon 2x plus 3. So we can write this as 2x plus 3 to the power -1. Now quickly tell me what is y1? Yes, -1, 2x plus 3 to the power -2 into, again differentiate 2x plus 3, you get 2. What is y2? -1, -2. So we can write this as -1 into 2 divided by 2x plus 3 the whole square. So can I write whole square as 1 plus 1? Square as 1 plus 1. So second derivative is -1 into -2, 2x plus 3 to the power -3 into, again you get 2. So we get 2 square. So we can write this as -1 की power, here -1 की power 1. So here -1 की power 2 into 2 factorial. 2 factorial कहाँ से है? ये 2 into 1 से, और ये 2 का स्क्वायर divided by 2x plus 3 का whole cube. So instead of writing whole cube, I write 2 plus 1. So I hope the point is clear to you. Now we can write y3 -1, -2, -3, 2x plus 3 power -4 into 2 का cube. Right? So we can write this as -1 की power 3 into 3 factorial into 2 की power 3 divided by 2x plus 3 की power 3 plus 1. So similarly, continue in this way. If we have to find the nth derivative, what is the nth derivative? So I directly write -1 की power n into 2 की power n into n factorial divided by 2x plus 3 to power n plus 1. So this is the nth derivative of given function y. So let us generalize this. If y is equal to 1 upon ax plus b, then prove that. So can you tell me what is yn here? What is yn? So in previous example, we have a and b. So a is 2 and b is 3. So instead of a and 2 and 3, I write 1 upon ax plus b. So what is yn? Minus 1 ki power n into a ki power n into n factorial divided by ax plus b ki power n plus 1. So if y is equal to x plus b, then prove that, so then prove that given any n in n, such that yn equal to this, and the derivative equal to this. So again, you can prove this by principle of mathematical induction. So by principle of mathematical induction, for n equal to 1, if I differentiate this one time, what we get? Y1 is equal to, so we have already differentiated this one time. So we get minus 1 to the power 1 into 2 upon 2x plus 3 to the power 1 plus 1. So can I write this as minus 1 into a divided by ax plus b to the power 2, or 2 means I can write 1 plus 1. So the result is 2 for n equal to 1. Right? Now assume that it is true for n equal to k. So if it is true for n equal to k, then yk is equal to minus 1 की power k, a की power k factorial divided by ax plus b की power k plus 1. So this result is true for n equal to k. Now we have to prove the result is holds for y equal to k plus 1 also. So what is yk plus 1? If we differentiate this, if this is star, if we differentiate star with respect to x, then we get yk plus 1 equal to minus 1 की power k minus 1 की power k into a की power k into k factorial. You can write this equation star as, you can also write this as, this is equal to minus 1 की power k, a की power k into k factorial into ax plus b की power k plus 1. So when we differentiate, we get k plus 1, ax plus b की power k plus 1 minus 1, so a की power k into again you get a. So we can write this as minus 1 की power, even you get minus k plus 1, not minus k, not k plus 1, minus k plus 1. So here you get minus 1 minus of k plus 1, minus of k plus 1 into a की power minus, not k plus 1, it is minus k plus 1 minus 1. Right? So you get minus k plus 1 minus 1. So we can write this as, you take minus common here, we can write this minus 1 की power k plus 1, a into a की power k, you get a की power k plus 1, k factorial into k plus 1, this is k plus 1 factorial into ax plus b की power. So we can write this as, because for yk you get it is minus ax plus b की power k plus 1. So we can write this as minus, you can take minus common. So it is k plus 1 plus 1. right? So you can also write this as minus 1 की power k plus 1, a की power k plus 1, k plus 1 factorial whole divided by ax plus b की power now k plus 1 plus 1. So the result is true for y equal to k plus 1 also. The result is true for n equal to k plus 1 also. So it means it is true for n equal to 1, and we assume that the result is true for n equal to k, and we prove that it is also true for k plus 1. It means you can take any natural number, the result holds true. So given any n in n, your yn is minus 1 की power n, a की power n factorial divide by ax plus b की power n plus 1. But y is, what is y? Y is 1 upon ax plus b. So the result holds for y equal to, if y equal to 1 upon ax plus b, then yn equal to this. Go through the result, try to solve step by step, and if you face any difficulty, try to create some example. Right? So one assignment to all of you, if try this part also. If y is equal to log of ax plus b, so prove that yn equal to minus 1 की power n minus 1, n minus 1 factorial a की power n divide by ax plus b की power n. तो ये अगर आप इस रिजल्ट को देखोगे तो ये सिमिलर कहीं ना कहीं आपको ये प्रीवियस रिजल्ट का यूज हेल्प होगी. बट हियर the first, the given function is y equal to log of ax plus b. So if we differentiate, then we get y1. What is the first derivative of log ax plus b? 1 upon ax plus b. And again we have differentiated ax plus b, so you get a. So we write a upon ax plus b. So you can take a to be common, then 1 upon ax plus b. Right? So this is y1. Now you have to find y2. So देखो y1 तो आपको ये जो मिला, यही तो आपको y गिवन था यहाँ पर, जो आपका यहाँ पर 0th डेरिवेटिव था, अब वो आपको यहाँ पर फर्स्ट डेरिवेटिव है. तो इसका nth डेरिवेटिव क्या होगा? अगर ये y1 है तो y1 है, तो इसका मतलब nth डेरिवेटिव एक कम हो जाएगा, माइनस 1 की पावर n माइनस 1 a की पावर n माइनस 1 फैक्टोरियल ax प्लस b की पावर n minus 1, right? So n minus 1 plus 1, you get n. So you get the same result. Minus 1 की power n minus 1, n minus 1 factorial a की power n upon ax plus b की power n. So this, after this, इस step के बाद आपको क्या करना है? पिछले वाला रिजल्ट का यूज करना है जो अभी हमने सॉल्व किया. एंड after the nth derivative of this function, you get this. So again you try to solve this by principle of mathematical reduction. And after that, when you solve this, try this. Y is equal to log of 2x plus 3. Y is equal to log of x. Right? So try to find out the nth derivative. So to this, what we have discussed, we have take various function. Y is equal to x plus b की power m, and we have find yn. Second, we take 1 upon ax plus b की power ax plus b, then we differentiate in time. And third part, we take y is equal to log of ax plus b, and we try to find out yn So in this case, we use the previous example, previous article, that y is equal to 1 upon ax plus b, then y equal to this. So we try to solve some more examples related to these articles. Go through the video lecture. I hope you will enjoy this session. We will meet with new session, new lecture in the next video lecture. Thank you. Have a nice day.